Welcome back to the real number system. In this video, we'll continue our discussion of division of whole numbers. So let's get started. Let's begin by thinking about our division algorithms. We'll start with what's called the concrete model for division. This model uses set theory and uses our base 10 blocks. Now remember, our base 10 blocks, we have 10 units make a long, 10 longs make a flat, and 10 flats make a block. So let's suppose we want to use base 10 blocks to divide 234 by 2. We'll start by pulling out the base 10 blocks for 234. We need 2 flats, 3 longs, and 4 units. When we divide by 2, this tells us we want to put our base 10 blocks in groups of 2. So let's think about our flats. We have 2 flats, so we already have a group of 2. So I'm just going to bring down those 2 flats. I need to put my longs in groups of 2. So when I do that, I would have 2 longs and 1 long. That makes a total of 3. Then bring down the 4 units. Now I know it seems weird right now because we haven't quite put all the longs in groups of 2 yet. We have 2 longs, that's a group of 2. We have that 1 long that's by himself. We'll get to him in just a minute. So bring down your 2 flats and your 2 longs. Remember that 1 long is the same thing as 10 units. Now since that 1 long is by himself, he's not part of a group of 2, we're going to exchange this 1 long for 10 units. So that's going to give us a total of 14 units. Now I have 1 group of flats, 2 flats that is. I have 1 group of longs, and again we're looking at 2 longs in a group. And to find my groups of 14 units, I'm going to draw 14 dots to represent my 14 units, and I'll put those units in groups of 2. Now notice that I have 7 groups of units, 7 groups of 2 units. So we have 1 group of flats, 1 group of longs, and 7 groups of units for 117. Let's look at another example. So here we have 381 and we're dividing by 3. So 381 would be 3 flats, 8 longs, and 1 unit. When I divide by 3, that tells me that I want to put my pieces in groups of 3. Well, the 3 flats, we have a group of 3. I want to divide my 8 longs into groups of 3. So that would be 3 longs, and 2 longs. That's a total of 8. And bring down your 1 unit. Now, just as we did in the previous problem, I've got a group that only has 2 longs in it. And I'm going to have to exchange those longs for units. Bring down the 3 flats. Bring down the 2 groups of 3 longs. And remember, 1 long is 10 units. So 2 longs are going to be 20 units. That gives us a total of 21 units. I have 1 group of 3 flats. I have 2 groups of 3 longs. And my 21 units, I'll draw 21 dots to represent those units. Then put those units in groups of 3. Notice that there are 7 groups of 3. So we have 1 group of flats, 2 groups of longs, and 7 groups of units for 127. Our next algorithm is called the partial quotients algorithm. Now this one uses repeated subtraction, a little different form than what we saw with our model, but it is going to use repeatedly subtracting something here to divide. So here we have 234 divided by 2. So I divide 2 into 234. Now I'm going to start by thinking about my first place here is my hundreds place, and I have a single digit is my divisor. So I'm going to think about a group of 100 twos. So 100 twos is 200, and I'm going to subtract out the 200. Now that leaves me with 34 twos. Now I'm going to start thinking about 10 twos. Well, 10 twos is 20. So I'm going to subtract out 20. That leaves me with 14. And now 7 groups of 2 is 14, and so I subtract 14, and that leaves me with 0. Now notice that my answer is going to come from the right side of my problem, a little different from what you're used to with division. I have 100 plus 10 plus 7. These are my groups of 2. Gives me 117, or here, 117 groups of 2. In part B, we're going to divide 32 into 4,224. Now, if I start to think about that first place in my dividend is the thousands place, and I think about 1,032s, well, that's 32,000. That is obviously way too big. So let's move to hundreds. A group of 100 would be 3,200. So I'm going to take out 3,200. So I subtract, and I'm left with 1,024. So then I think about 10 32s. Well, 10 32s is 320. So I subtract 320. That leaves me with 704. I can take away another group of 10 32s. That leaves me with 384. I could take away another group of 10 32s. That leaves me with 64. So now I can no longer take out 10 32s at a time. I'm going to have to take out a single group of 32s. So a single group of 32s is 32. I take out 32, leaves me with 32. Take out another group of 32, and that leaves me with 0. Again, I'm adding my groups of 32. So I had 100 plus 10 plus 10 plus 10 plus 1 plus 1, and that gives me 132. Our next algorithm is called the scaffold algorithm. Now, this algorithm is similar to what we just saw in the partial quotients algorithm. But rather than writing our groups of 2 out to the right, we're going to scaffold them on top of the doghouse, or that division symbol. So here we're dividing 6 into 726. Now notice I left a space at the top of my division symbol because I'm going to scaffold my answer on the top there. Think about your groups of 6s. We're going to start with 100 6s. Well, 100 6s is 600. Of that 100 6s, that leaves me with 126. Then I think about my groups of 10 6s. Well, 10 6s is 60. 20 6s is 120. So I'm going to take out 120. That leaves me with 6. Now I'm going to think about single groups of 6. And one group of 6 is 6, and that leaves me with 0. The scaffold algorithm is different because we add up, and that makes many students uncomfortable. But I add 100 plus 20 plus 1 gives me 121. Let's look at part B. Now remember to leave a space between your problem and your division symbol. So let's start thinking about our groups of 25. Well, I have the thousands place, 5,768, as my dividend. But 1,025s is 25,000. That is too big. So let's think about 100 25s. Well, 100 25s is 2,500. Okay, so what would 200 25s be? Well, 225s would be twice that much, or 5,000. So I'm going to take away 225s, or 5,000. That leaves me with 768. Then I start thinking about my groups of 10. So 10 25s is 250. 20 25s is 500. 30 25s is 750. So I take away 750, or 30 25s. That leaves me with 18. Well, I can't take away any more groups of 25s. And so notice my scaffold on top of my division symbol gives me 230. And here I have a remainder of 18. Our next algorithm is long division, which is probably the algorithm that you learned in elementary school with what many people call the doghouse. And guess, multiply, subtract, pull down. We're going to divide 8 into 978. Well, 8 goes into 9 one time. 1 times 8 is 8, so I have to subtract 8. 9 minus 8 is 1. Now bring down the next digit, which is an 8. 8 goes into 18 2 times. 2 times 8 is 16. Subtract here leaves us with 2. Bring down the next digit, which is 7. 8 goes into 27 3 times. 3 times 8 is 24. And when we subtract, we're left with 3. So our answer here is 123 with a remainder of 3. Look at part B. We have 31 into 8,974. The trick that I use here many times is I look at maybe the first digit. So 3 goes into 8 2 times, so let's try 2. 31 times 2 is 62, and I subtract gives me 27. Now, if I had gotten a number bigger than 31, I know that the 2 that I tried up top of my division symbol is too small and I need to try a larger number. Remember, we talked in the last video that my remainder, the 27 here, has to be less than the divisor, the 31. Now bring down that next digit, which is 7. Again, I'm going to kind of think about my first digit into the first maybe 2 digits. 3 goes into 27 9 times. Well, in my head, I think about 31 times 9. That's 279. It's too big. So let's try 8. 31 times 8 is 248. And when I subtract, I end up with 29. Still less than my divisor. Remember, whatever's down here as part of the remainder has to be less than that divisor. Bring down your 4, that next digit. And we talked about that 31 times 9 is 279. So subtract 279 and you're left with 15. Our answer then is 289 with a remainder of 15. This brings us to our mental computation. Now, as we move to the mental mathematics, remember that what we show on paper is what would be completed in our heads. But on show work problems, on your quizzes, you're going to have to show the same work that I show here in the video. Our first strategy is breaking up the dividend. So we break the dividend into parts that we can divide. So here I have 4,256 divided by 7. Well, when I think about it, I know that 7 will go into 4,200 and 7 will also go into 56. So you'll notice I broke up the dividend into 4,200 plus 56. Well, 7 goes into 4,200 600 times. 7 goes into 56 8 times. And 600 plus 8 is 608. Again, this would be completed in your head, but on a show work question on the quiz, this is the work that you will be expected to show. Part B, we're going to divide 31 into 9,362. Well, I know that 31 will go into 9,300, and 31 will also go into 62. So I broke up 9,362 into 9,300 plus 62. So 31 goes into 9,300 300 times, and 31 goes into 62 2 times. 300 plus 2 is 302. Our next strategy for mental mathematics is using compatible numbers. So we're going to look for numbers that we recognize are divisible by the divisor. Our first example here, we have 105 divided by 3. Well, I know that 3 goes into 90 evenly, so I'm going to start with 90. Well, 90 plus 15 is 105, and I also know that 3 divides into 15. So 3 goes into 90 30 times, 3 goes into 15 5 times, and 30 plus 5 is 35. This is very similar to what we did with the breaking up the dividend. In part B, we have 232 divided by 8. Well, I know that 8 goes into 200, and so I can break up 232 into 200 plus 32. 8 goes into 225 times, 8 goes into 32 4 times, and 25 plus 4 is 29. Now that brings us to our estimation. With estimation, we can also think about our compatible numbers. But remember, with estimation, this is an estimate and not the actual answer. So be careful that you don't confuse compatible numbers with estimation and mental computations with our compatible numbers that we just looked at. So here I'm going to estimate. So this is not going to be the exact answer like we saw in the previous example. I'm going to round 4,163 to 4,000. So I'm going to divide 5 into 4,000. 5 goes into 4,800 times. And again, this is an estimate. In part B, let's round 401 to 400. And we're going to round 8,005 to 8,000. 400 goes into 8,000 20 times. And again, this is an estimate. That brings us to our order of operations. So when we have more than one operation, we need a certain order to be sure we get the exact answer. Now, a couple of things is multiplication and division are paired together and they're performed in order from left to right. After multiplication and division is addition and subtraction. Again, they're paired together and carried out in the order that they occur from left to right. You can remember the order of operations if you remember the acronym PEMDAS. P stands for parentheses or any grouping symbols. E represents our exponents. M and D is our multiplication and division, again in order from left to right. And A and S is the addition and subtraction in order from left to right. Now be careful that you don't teach students that we do all the multiplying, then all the dividing, then all the adding, and then all the subtracting. This is a common mistake. Multiplication and division are of equal importance, so we do them in order they occur from left to right. The same is true for addition and subtraction. So let's evaluate each of the following. We're going to start in part A with the parentheses. PEMDAS, parentheses, comes first. So 7 minus 4 is 3. Bring down the rest of the problem. E stands for the exponents. We don't have any exponents here. M and D, multiplication and division, again go together from left to right. 5 times 3 is 15. And then 6 divided by 2 is 3. Bring down the minus 8. Addition and subtraction are performed from left to right. So 15 plus 3 is 18, minus 8 is 10. In part B, we don't have any parentheses, we don't have any exponents. So we start with our multiplication and division. They are performed in order from left to right. So here the division is performed first. 9 divided by 3 is 3. Bring down the rest of the problem. We still have multiplication. Multiplication comes before addition and subtraction. 3 times 2 is 6, and bring down the rest of the problem. 8 minus 6 is 2, plus 3 gives us an answer of 5. And last we have part C. Here we do have parentheses, so we're going to start with our parentheses, and we'll start with the 10 minus 5 in parentheses. Inside parentheses, we still follow our order of operations. So addition, subtraction from left to right. 10 minus 5 is 5. Bring down the rest of the problem. Again, we have our parentheses. 5 plus 4 is 9. And 54 divided by 9 is 6.